Hey there, Geometry. Thanks for tuning in for another episode of Math with Mullins. We're going to try to get through this episode without me having a coughing fit because I'm currently sick. So here we go. We're looking at lesson 3.1 today, conjectures and counterexamples. So write and analyze conjectures by using inductive reasoning, and then disprove conjectures by using counterexamples. There's a lot of definitions in Unit 2, starting with lesson 3.1. So give yourself some grace writing all this down. I'll try to remind you to pause the video whenever you need to write some stuff down, but we're going to start with inductive reasoning. Inductive reasoning is the process of reaching a conclusion based on a pattern of examples. Okay? So for example, let's say I have the times 8:30 a.m., 9:15 a.m., 10 a.m., and 10:45 a.m. Okay? These are examples of appointments. And what we can say is a conjecture for the next piece. Okay? So a conjecture is going to be making an educated guess based on the known information and examples. So I'm going off of what we just wrote up here. Each appointment time starts 45 minutes after the previous time. Or you can even say each appointment is 45 minutes long. A counterexample would just be a number, drawing, or statement to prove a conjecture is not true. Okay? And we'll talk about more of that in a moment. Make sure you take some time now to pause the video, write down what you need, and when you're ready, click play. All right, example 1. Write a conjecture that describes the pattern in the sequence. Then use your conjecture to find the next term in the sequence. So we notice that we have temperatures of 65, 58, 51. So the temperatures are decreasing by 7 degrees each time. So the next term in the sequence would be 44 degrees. Okay? Example 2, same thing. Write a conjecture that describes the pattern in the sequence. Maybe pause the video here and try on your own. When you're ready to check it, click play. All right, what we're noticing here is the next number is being doubled. So the next number is 2 times the preceding number. So the next number in the sequence is 8. All right, going on to example 3, so we're flipping our page. Make a conjecture about the sum of the squares of 2 consecutive natural numbers. So I'm going to make kind of like here's a list you should be thinking about. So step 1, list some examples. Step 2, look for a pattern. And then step 3, make a conjecture, which is an educated guess. Okay? So I'm actually getting my writing utensil out here for this. So consecutive natural numbers. So natural numbers start at 1 and you just count up like 1, 2, 3, 4, 5, 6. So consecutive would be like 1 squared plus 2 squared. Okay? 1 squared plus 2 squared is equal to 5. Let's do some more examples. 2 squared and 3 squared. Consecutive, right next to one another. 9 plus 4 is 13. Let's do 3 squared and 4 squared. 9 plus 16 is 25. 4 squared and 5. Let's do even like 7 squared and 8 squared. Okay? 49 plus 64. 113. Okay? When we are doing this, these are all odd numbers. Okay? So maybe a conjecture I can make here is the sum of the squares. So I'm just repeating what it says in my example of 2 consecutive natural numbers is an odd number. Okay, that's a true statement. That's all you're really allowed to do. Okay. All right. Example 4, make a conjecture about the product of two odd numbers. So product of two numbers would be like this. 1 times 3, that's 3. 3 times 5, that's 15. 5 times 7, 45. 7 times 9, 63. Okay? So what I'm noticing here is all my answers are odd again. So the product of two odd numbers is an odd number. That easy. Okay? Sometimes we get a nice little picture and it says choose the correct conjecture that describes the pattern and the sequence. So maybe take the time now and pause the video here. When you're done, click play and see if you got your answer correct. All right. The correct answer would be letter B. The shaded quadrilateral is moving 2 sections clockwise each time. Okay? So clockwise is this way from one figure to the next. So let's draw the next figure in the sequence. I'm going to do my best here. We're going to draw a big old plus first, and then it's like going in like this at an angle. You get the idea. And then if we're here from that one, 2 clockwise would be down here. So shading this portion in. Okay? Yay! Example 6. Flipping the page, the owner of an ice cream shop collected data on total sales for the first 5 months the shop was open. Predict sales for the 6th month. If you look at for a pattern, that usually can help you. So 500 to 200, 500 to 700 was $200. Next one was 250. The next one was 300. So we got 350 here. So I'm going to predict we're going to increase by 400. So the 6th month, we would predict $2,000. Okay? Here we go, some counterexamples. Find a counterexample to show that each conjecture is false. Reminder, counterexample is a number, a drawing, or a statement to prove the conjecture not true. If n is a real number, then negative n is a negative number. Well, not necessarily. N could be negative 30. So negative n would show negative 30, which is actually equal to a positive number. So this proves it would not be a negative number and instead a positive number. Okay? Next one definitely helps to draw a picture for. If ABC's angle is congruent to DBE, then angle ABC and angle DBE are vertical. Okay? Notice that they both have a vertex of B, but they don't have a matching side. So what could be happening is you've got like, here's ABC, and then here is DBE. Aren't these matching? But they're not vertical. So here they're showing these angles, ABC and DB, are congruent, but they are not vertical. Okay? So that's one way you can prove it. That's with the drawing. C, if a line intersects a segment at its midpoint, then the line is perpendicular to the segment. Not always. Example, A, B, midpoint. Doot, doot. Sometimes it can be perpendicular, but other times you can draw it like this. That's not a 90-degree angle, right? So here, a line intersects a segment, come on, but does not show a perpendicular line. A line intersects a segment at its midpoint. Great. The last one, pretty easy to decide. If n's a real number, then n squared is greater than n. Well, I'm thinking if I say n is 1 squared greater than n? No. So that's false. You could also do 0 squared. 0 squared is not greater than 0. Okay? So those are just some things to consider for when we see conjectures, counterexamples, some inductive reasoning. So yeah, thanks so much for tuning in for lesson 3.1. We hope to see you back next time. Have a great day.